equations. It's named after Gabriel Cramer, who lived from 1704 to 1752. So a little bit about him. Okay, obviously he wasn't that old. Okay, at age 18 he was awarded a doctorate. Yeah, a doctorate.
What's that?
That's like you have your bachelor's degree, your master's degree, and then your doctorate.
Is that like 6 years or 8 years?
It's a long time, depending on. So at age 20, he was awarded the co-chair of math at the Académie de Clavien in Geneva, Switzerland. Okay, so he was like the co-chair of the math department there. And then at age 30, he was just awarded the chair of the math department there. So pretty smart guy. And he came up with this way. And this is a way using matrices that we can solve a system of equations. And so this actually uses determinants. And so you might want to get this down. Okay. This is how we can use determinants to solve a system of equations. First of all, if we want to find x, we take dx divided by d. If we want to find y, we take dy divided by d. And if we want to find z, we need to take dz divided by d. Now you're probably wondering, what is all this dx, dy, and dz? We'll go ahead and look at, two examples. And we'll go through how you use Cramer's rule to solve those.
Okay.
So let's go ahead and look at an example here. It says solve by using Cramer's rule. Okay. And so we have a system of two equations and two variables. Okay. So in this problem, we're going to have a d, a dx, and a dy. We won't have a dz because there's not a z variable. So we're going to start by finding matrix D. Okay? Matrix D is found by finding the determinants of a 2 by 2 matrix. And so now we need to decide what matrix are we going to use. Well, matrix D is going to be the numbers to the left of the equal to sign. So the numbers to the left, if you notice, are 4, negative 2 on the top row. What about on the bottom row? 3, negative 5. So now all I need to do is find the determinant of that. And we learned this yesterday. Yesterday, remember, we multiply along the diagonal. So along that first diagonal, I get negative 20 minus the second diagonal. What do you get? Negative 6. So negative 20 minus negative 6 plus a positive is negative 14. So there's what D is. Now what I need to do is find dx. So to find dx, once again, I've got a 2 by 2 matrix. So what I'm going to do now is I'm going to use the numbers I haven't used yet, the 10 and the 11. And in place of the x column, so notice here's the x column here, the 4 and the 3, I am now going to put the 10 and the 11. That's why we call it d sub x. Okay, so I'm going to put the 10 and the 11. The y column will stay the exact same, negative 2, negative 5. So multiply along the first diagonal, what do you get? Negative 50 minus negative 22. Your answer is negative 28. Very good. So now I need to find d sub y. So to find d sub y, I'm going to once again take the numbers to the right of the equal to sign. And instead of putting them in for x, I'm going to put them in for y. So my x column will still stay 4, 3. Not going to adjust that any. The y column now becomes 10, 11. Very good. So let's go ahead and multiply that. What do you get? 44 minus 30, which is 14. So now in order to get my solution, this is what you're going to do. I've got an ordered pair here. I'm going to take dx divided by d And then I'm going to take dy and divide it by d. And that's all you're going to do. Okay? So dx is negative 28, and I'll even write it this way, divided by negative 14. dy is 14 divided by negative 14. So what is my solution going to be?
Negative 2, negative 1.
Perfect. Negative 2, or positive 2, negative 1. Because you got two negatives there with the negative 28 and the negative 14. So that's your solution. Okay, now the 2 by 2s are obviously a lot faster because the next one we're going to look at is a 3 by 3. Okay, and we're going to kind of divide this and conquer as a group. Okay, but we're going to solve that following one using Cramer's rule.
So are these the same kind of problems that we did like
Yep. These are the same type of problems that you did with elimination and substitution. And if you remember, I said there is in fact another way to solve those, and this is the other way. Okay? The thing about this is when and if like you would get to college and you would have to learn about matrices, there are graphing calculators that calculate the determinants pretty quick. And so that would save you some time because you could just type your numbers in and it would give you the determinant. Unfortunately, we're not going to do that.
Unfortunately.
Okay. Unfortunately.
Happy about that.
So anyway, this is what we're going to do. Okay, I'm just first of all going to write the determinants. So what would just D be? What's D going to look like? 4.
Negative 2, negative 2, 1, 3, 6.
Okay. Then we've got dx. Dx will be, let's see how well you pick up on this one.
Negative 5, 10, 1, and then
Negative 5, 10, 1. Very good.
the y and the 3.
And then the y and the z stay the exact same. Okay? Because remember, what we do is we use the numbers to the right of the equal to sign, and I just replace the x column. Now, I've got the y column, dy. Okay, so dy, the x column stays the exact same. So the x column will still stay 4, 2, 5. What does the y column become?
1, 5, 10.
And then the z column becomes 1, 3, and 6. And then last but not least, the dz. Your x and your y stay the same. And then what does the z column become? Okay, so as I said, we're going to divide and conquer because these obviously, if you remember, take a little bit of time because what we do is we add the extra 2 columns in. Okay, so this is what I want you guys to do. I want these 2 tables here. I want you to do d. I want these 2 tables here to do dx. I want these 2 tables here to do dy. And I want you 2 tables to do dz. Okay? So once you figure out what it is, I just need you to go ahead and let me know what you get. So if you remember, we do down minus up. Remember from yesterday? So you're going to go ahead and multiply your down column here, down, and down. Negative 14.
You set them up side by side. And then you put this next to the other side.
Actually, I 110. Sorry.
Okay. Yeah, exactly. Okay, that's -5. Oh wait, what was it? You're doing the wrong. You're doing
Take the ones going down. First take that one minus the one red. Should be 22 minus -1. It was -22. I was right, Casey. It's -50.
Negative, yep, yep.
No, -110. No, it's positive 110. That's 1 I listen to you sometimes, and then the other times. That's wrong.
Okay, so D, what did we get? 55. Okay, DX, what did we get? -55. DY, what did we get?
165.
Good job. And DZ, what'd you get? 110. So now in order to find our solution, what I'm going to do is I'm going to take DX divided by D. I'm going to take DY divided by D. And I'm going to take DZ divided by D. So now if I take -55 divided by +55, I get -1, 3, 2. There you go. Generally, when you do these, you're going to come up with whole numbers, or at least that's kind of how the book has designed these. So if you aren't coming up with a whole number, probably come see me and we'll look at it and make sure that you've done things correctly. So now this is what I need you to do. You need to add a few problems to your homework, and you have the rest of the time to work, and that's on page 195, 39 through 46. So you need to go ahead and add those. Now remember, these are going to be due what day?
Monday.
Monday, okay? Yep. Okay, so due Monday.